In question 6, we are looking at computers, and we're told that a computer screen is the length of its diagonal. And in this particular case, we are looking at a screen that's 68 centimeters. We've got y, which is the height, and x, which is the width, and we're asked to use this information to write down an equation involving x and y. So it should be fairly straightforward to see that we can use Pythagoras there to make a relationship, which would be a squared plus b squared equals c squared using the generic form. So here your a and your b are going to be the base, which is x, so x squared plus the height, which is y squared, is going to equal the hypotenuse squared, which is 68 squared. In part B, we're told that the ratio between the height and the width of the screen is 3/4, and we're asked to use this to write down y in terms of x. So we know that the ratio of the height to the width is 3:4. So in effect, we've got this relationship here, which we can rewrite to give us y is equal to 3/4 x. And then in part C, we are asked to find the value of x and y. So in effect, we're going to have to use simultaneous equations here. We're going to have to use our value of y that we found here and substitute that back into our original equation. So we're going to have x squared plus 3/4x all squared is going to give us 68 squared. So if we can expand the brackets, that's going to give us x squared plus, remember, if we distribute this is in effect 3/4 squared x squared, and then we can distribute the squared to each of those. So 3 squared is 9, 4 squared is 16, so 9/16 x squared is equal to 68 squared. So therefore that is going to be 25/16 x squared equals 68 squared, and from that we can therefore multiply 68 squared by 16 and divide by 25 to give us x squared. And if we take the square root of that, we should solve to get x is equal to 54.4 centimeters. And then remember to work out what y is. We can take that value, substitute it into here, and we'll end up with a value of y equal to 40.8 centimeters.